Welcome back. In this section, we are going to primarily focus on Docker fundamentals. So what are the topics involved in understanding the Docker fundamentals? Let's go ahead and then see that now. So we are in our github.com/stacksimplify Git repository. So in that, there is one repository called Docker-fundamentals. So if you go inside, we have 5 sections involved in this understanding and then learning the Docker fundamentals. Okay, so we are going to first understand what is Docker, and then in traditional approach, what are the problems we are having, and then why with Docker, how we are going to solve it, and we are going to understand the Docker terminology or Docker architecture. So once all that is covered in first section, then we'll move on to the Docker installation. So in Docker installation, we'll focus on installations on Windows, Mac, and also troubleshooting Docker desktop issues on Mac. So from there on, we'll move on to 2 major flows which are more essential for understanding the Docker. So the primary flow is like pull a Docker image from Docker Hub and then run the Docker image as a container. So we have existing Docker images available for different applications, and then how we need to pull that and then run it on our local Docker machine, we are going to see it. In addition, the flow 2 is like build a new Docker image and then run it locally and then again push it back to the Docker Hub. So how we are going to do that? So if we understand basic these 2 flows, so we are very good with the Docker in the sense like we got the fundamentals thoroughly. In addition, we'll also focus on essential Docker commands. So the Docker architecture, what we are seeing already covered in Docker introduction. So we really don't need to worry about it. Okay. But the core thing is we are also going to focus on essential Docker commands on day-to-day life, what we are going to use when we are using the Docker. So this is the core things we are going to perform now. So I'll see you in the next lecture with the Docker introduction. Until then, bye-bye. Thank you. Welcome back. So in this lecture, we are going to focus on 01 Docker introduction. So as part of Docker introduction, we are going to see what problems we have with the current traditional infrastructure and then how Docker is going to solve them. In addition, what are the advantages of using the Docker we are going to look into. So for presentation slides, you can click on this link and then view the presentation slides. So the slides, whatever we are showing in these lectures is also available here for you for download. So moving on, so if we go to the 01 Docker, so we have something called Docker architecture, right? So in addition to Docker introduction, we are also focusing on Docker architecture. So Docker architecture is like a series of terms in Docker introduced, which we need to be aware of to understand and then play with Docker effectively. So what is Docker daemon? And then what is Docker client, or what are Docker images, and then what are Docker containers, and what is Docker registry or Docker hub. So all these terms, whatever is introduced in Docker, so we are going to understand as part of the Docker architecture or Docker terminology section. So let's go back to our introductory slides and then move on with the stuff. Okay. So in Docker introduction, so first thing is what problems we have with the traditional infra. So let's see what are the problems we are having. So in the traditional infra, we have the hardware infrastructure. On top of that, usually we install our respective operating system like Ubuntu or SUSE Linux or Red Hat or CentOS, whatever it is. And then when we are planning to deploy our applications, its equivalent OS level libraries we install and also its equivalent dependencies we install. So let's consider we have web servers as Nginx and then app servers as some Spring Boot applications which are of Java type, and then we also have databases as MySQL. So for those things, what are the OS libraries required? We need to install them, and then also the dependencies. Example, if you want to run some JBoss or Tomcats, then you also install the JDK and all those things, right? So like this, what all dependencies of libraries and dependencies are required, we need to install and then handle them. So now, if you see, installation and configuration will be a biggest problem in the traditional approach. Okay, so it is going to be time consuming, and we need to perform all these library install, dependency install, and then these vendor product installs, all these things across our environments like dev, QA, staging, and then all the production environments. So multiple times we need to implement them. But when you consider Docker, so from Docker perspective, package it once and then leverage it or use it across all the environments. So one time work, and then after that everything is like packaged and then it can be leveraged across environments. Compatibility and dependency, right? So we need to keep resolving issues related to libraries and then dependencies continuously. So if we do the OS upgrade, then what happens? Again, the libraries, some libraries might break, and then we need to fix those libraries, or we need to fix the dependencies, or we need to upgrade the dependencies. So like that, we face multiple issues from compatibility and then dependency issues when we are on the traditional infra. And inconsistencies across environments. So if you have multiple 5 dev environments, 5 QA environments, 5 staging environments, and 2 production environments, it is very hard to track changes across these environments, and they end up with multiple inconsistencies. But when in Docker, if you package it once and leveraging it across all the environments, so then there is no chance of missing or having the inconsistencies in our Docker images. Operational support. So we need more resources to handle operational issues on a day-to-day basis, because of you are going to scale your hardware infrastructure heavily to support your operating system and the needs from your environment's perspective, right? So the server support, hardware and then software installations, and then patching releases, all these things, we need to spend a lot of money and then lot of resources to handle all those things. When it comes to Docker, all these things will be simplified. So in addition, developer environments. So when a new developer joins the team, the time it takes to provision his development environment in traditional approach is time taking. And even most of the time it will not be 100% right. But when we consider our developer environments are Dockerized, then it is going to be a minute or less than a minute to provision that respective developer's environment. So all these problems, whatever we are seeing in traditional infra, can be easily solved using Docker. Moving on, so let's see how a physical machine looks like when we install the application. So we have hardware infrastructure, operating system, libraries, dependencies installed on that operating system, and we have deployed the web servers, app servers, and then databases on that physical machines. So let's see from physical machine to virtual machines, what is the difference, right? So we have the hardware infrastructure, and in virtual machines, we'll have the hypervisor, and on hypervisor, we create the virtual machines. So we have the operating system for each virtual machine, and then we'll install the libraries and then dependencies for those virtual machines, and then we'll have the equivalent containers, equivalent vendor products installed on those virtual machines. Okay, so now if you see here, this is a little bit simplified version from the physical machines, but still the libraries and then dependencies and then all these incompatibility issues still going to be there across environments, and then you need to solve these things. But in virtual machines also, there is a concept of creating a virtual machine image and then leverage it across environments. We have seen that, but still with IP address changing, DNS name changing, and then lot of other things we need to bring into the picture when we are even using the virtual machines OVA images or whatever is it. Okay, so moving on to Docker. So when it is installed on a physical machine with Docker, it is going to look like this. Okay, so we have a hardware infrastructure and we have the operating system. On that, we are going to install the Docker, and then we are going to run the containers. So each container is a combination of its own libraries, dependencies. It will have its own operating system inside that, and then we'll be installing the Nginx or even the app servers and then databases, whatever it is, they'll have their own libraries and then dependencies, so that once and for all we are solving the libraries and dependencies, and then we are going to package and then use that Docker image across all environments. So if you see here, so on the operating system, we are going to install the Docker. In the same way, if you see virtual machines with the Docker, so we have the hardware infrastructure, we have the hypervisor, and on that we are going to have the operating system for that virtual machine, and then we are going to install the Docker, and then from there we are going to deploy our Docker images as containers on them. So we can run multiple Docker containers in a single virtual machine, right, based on the memory and then CPU limits, whatever we have. So like this, you can run 100 containers or 200 containers, all those things. So nothing, there is no dependency from our perspective from either hardware infrastructure or hypervisor perspective. Okay, so if this respective operating system is allocated with equivalent CPU and then RAM, and then if those are minor containers, then you can run any number of those things. Okay, so but with that said, the core thing here is like Docker is flexible for us. The way how we want to use it, we can use it in a better manner. Moving on, so what are the advantages of using Docker, right? So why containers? So they are flexible. So even the most complex applications can be containerized in our recent days. So they are very lightweight, and containers leverage and share the host kernel, making them much more efficient in terms of system resources than virtual machines. So they are very portable. So you can build locally, deploy to the cloud, and then run anywhere. So they are very loosely coupled. These Docker images or Docker containers are loosely coupled. Containers are highly self-sufficient and encapsulated, allowing us to replace or upgrade one without disrupting others. So they are very much scalable. You can increase and automatically distribute container replicas across a data center. So they are very much secure. Containers apply aggressive constraints and isolations to processes without any configuration required on the part of the user. So with that said, the Docker containers are flexible, lightweight, portable, loosely coupled, scalable, and then even secure. So now moving on, we'll be looking into the Docker architecture in our upcoming lecture. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. So let's see the Docker architecture now. So, or even we can call it as Docker terminology. So we have a Docker host, and inside Docker host primarily we'll install the Docker daemon. So the Docker daemon, Dockerd, listens for the Docker API requests and manages Docker objects such as images, containers, networks, and then volumes. So the next is the Docker client. Okay, so Docker client is an optional thing in the Docker host. So we can either install on the Docker host or on our own desktop, and using the Docker client we will be able to communicate to the Docker daemon. So Docker client can be present on either Docker host or any other mission. So the Docker client, Docker is the primary way that many Docker users interact with the Docker. So when you use commands such as docker run, the client sends these commands to Dockerd, which is nothing but Docker daemon, which carries them out. So the Docker command uses the Docker API. So the Docker client can communicate with more than one respective daemon. Okay, so moving on, the next thing is the Docker images. You can see here the image 1 and then image 2. So an image is a read-only template with instructions for creating a Docker container. So often an image is based on another image with some additional customizations. So example, like we may build an image which is based on Ubuntu image. So we already have a Ubuntu image, and then consider that image we are taking and then building our own image using that Ubuntu image. So with that Ubuntu image we install additional application options of what we are planning to use, which is like Apache web servers or Java, JDK, and then additional Tomcats, whatever we want to install, and then deploy our application inside that, and then package it as our own application image. So the base image there we are using is the Ubuntu image. So that is called image is based on another image. So moving on from Docker images, the next thing is the Docker containers. So a container is a runnable instance of an image. So we can create, start, stop, move, or delete a container using the Docker API or CLI. So we can connect a container to one or more networks, attach storage to it, or even create a new image based on its current state. So when a container is removed, any changes to its states that are not stored in persistent storage disappear. So that's most important point from containers perspective. So moving on, so let's see, we have a Docker host, and on Docker host we have the Docker daemon. So if you want to pull the image and then run it as a container, so what's the process going to be? Let's go ahead and then see that now. So Docker client, it can be my desktop or even the Docker host. So what we do is like Docker client is nothing but the Docker command, DOCKER. Okay, so I'll say Docker pull nginx demos /hello. So one sample image. So what happens is it will go and then communicate to the Docker daemon, and then via Docker daemon it will go to the Docker registry, right? So from Docker registry I'll try to pull the nginx demo /hello and then download that image to my Docker host. So from my Docker host, so the image is present here. So now I'm going to run it, right? So to run it, I'm going to say docker run and then some -port, local port, and then image port, whatever it is there, and then -d and then the complete image name. So whenever I do that, it is going to run it as a container in the Docker host. So what we have done, so first we have pulled the image from the Docker registry and then stored it as images here, and then we have run it, and then now the runnable instance of an image is called the container, which means like the container has started and then application started serving. So now in this overall thing, you have seen client and then host, but you really don't know what is this registry or Docker Hub, right? So let's see what is this. Okay, so a Docker registry stores the Docker images. So Docker Hub is a public registry that anyone can use, and Docker is configured to look for images on Docker Hub by default. So we can even run our own private registry in our cloud systems like Elastic Container Registry, or using Docker Hub also you can even run it, means like the Docker provides the software to run it as a private registry in our local data centers. So when we use the Docker pull or Docker run commands, the required images are pulled from our configured respective registry, right? So when we use the Docker push command, our image is pushed back to the registry. So we are going to see two flows. By seeing what we have seen here, the complete thing we are going to distribute into two flows and then implement them in our upcoming lectures. So the flow one is to what we have seen here, like pull our container image here and then run it as a container, right? So the second flow is like build a image here, run it as a container locally, and then test it and finally push it to the Docker Hub. So we are going to see all those things now in a step-by-step manner. I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. So in this lecture, we are going to look into Docker installation. Okay. So from Docker installations perspective, so let's click on the Docker install. And we can see here, so we can install the Docker engine, and then it is supported in different platforms. Okay. So CentOS, Debian, Fedora, and then Ubuntu, and with x86, AMD 64, ARM, ARM64, IBM Power, and then IBM Z series. So this is more or less like a Docker engine directly installed on those respective operating systems. So in addition, we have something called Docker desktop. So we have the server version and also we have the desktop version. So from server versions perspective, all these operating systems are supported, and these models are supported. Okay, so x86 64 or AMD 64, ARM, all those things. So now from desktop's perspective, so we can install Docker desktop for Mac on Mac OS, and also Docker desktop for Windows on Microsoft Windows 10. So let's start with the Windows, right? So when we click on that Windows, so you can see here, get started with Docker for Windows. So we can directly install the Docker desktop on our Windows machine and then test these things using these steps. So let's click on install Docker desktop for Windows. So we have the system requirements here. Our system should have Windows 10 64-bit, Pro, Enterprise or Education versions, and we should have the Hyper-V and then Hyper-V and containers Windows feature must be enabled on our operating system, means like at the OS level. Okay, so now our mission should minimum have 4 GB of system RAM to operate or run this Docker desktop, right? So once those are ready, so we can download the Docker desktop installer.exe and then run it. Okay, so we can start the Docker desktop and then we can start using it. Okay, so you can see here, and then you can run the Microsoft PowerShell, and then from there you can run the Docker run hello world, right? And then you can test it. So in addition to that, from Docker desktop only, you can even log into your Docker Hub ID. Okay, so that's about the Windows installation. So this Docker desktop is going to be pretty easy from install perspective if you have the exact system requirements. So primarily like if your system is of Windows 64-bit and then Windows 10 you are running and at least you have 4 GB system RAM, then it is good, okay. But from my observation, what I am saying is usually 4 GB system RAM, if you install this Docker desktop, then your system will be at the disaster. This is the live experience whatever I am having, okay. So ensure that your system has 8 GB RAM so that you can even leverage that for using other tasks other than Docker desktop things, okay. So if it is only 4 GB system, then it only supports for Docker desktop, and then most of the things whatever you run, either your Spring Boot IDE or Eclipse IDE or whatever you are running there, it is going to be a hell lot of a system where it will be very slow, okay. So 8 GB RAM is always recommended, even though it says 4 GB here, but in real world it's 8 GB is recommended, okay. So that's about the Docker desktop on Windows, okay. So moving on, so the next thing is Docker desktop on Mac, right. So if you see here, this is get started with Docker desktop for Mac, right. So install Docker desktop for Mac. So let's go there, and then so if you see here, so from system requirements perspective, if you are on the latest OS, it is already supported. So macOS must be version 10.13 or even newer. So this is the thing, and 4 GB of RAM, that's what they say as usual, and VirtualBox prior to version must not be installed. So all these things you can ignore, okay. So for this VirtualBox and all those things, okay. So directly download the Docker desktop and then move it to the application folder, and then once you have moved to the application folder, it will be available as a docker.app, okay. So you can run that, and then once you run this docker.app, so it will start displaying here. You can see it here, right. So Docker desktop is running on my Docker desktop, so it will be available for us to run it, means like it will be available for us to open it from here on, okay. So it's engine version, compose version, Kubernetes version, all these details are provided here. So once our Docker desktop is up and running on our Mac machines, so we can go here and then go to the preferences section and then ensure that this respective setting, okay, securely store Docker logins in macOS keychain, okay. So this setting should be unchecked, okay. So I already have a running version here, so I'm not looking into it, but ideally this setting should be unchecked. So let's see more about it, okay. So Docker desktop on Mac has an issue with the macOS keychain, okay, OS X keychain, okay. So to fix it, we need to perform these two steps. So one is go to Docker desktop changes, open Docker desktop preferences, which is nothing but whatever we have seen here, right, in preferences, and uncheck the option named securely store Docker logins in macOS keychain. So that is first thing, okay. And once that is done, go to the config.json file in .docker folder. So this will be there in your root folder, okay. So if you go to your users and then kdaida, my home user is, my user's home is users kdaida, and inside that I'll have a folder called .docker. And then inside that you will have something called config.json, okay. So currently I removed it earlier, so I am not finding it here, but you will find some line called cred store OS X keychain, okay. So this line, okay, so you just need to remove this and then restart the Docker, okay. So restart the Docker daemon. So you can see here, you can say restart, okay, somewhere it should be there here, yeah, restart the Docker daemon. So when you do that, so this issue will be resolved. If you face any issues related to this OS X keychain, ensure that you are going to troubleshoot when it is on Mac using following things, okay. So other than that, on Mac you are not going to face any other issues, only this issue you will face, and then you can fix it using these things, okay. So in our next lecture, we'll focus on our flow one, which is pull from Docker Hub and then run the Docker image. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to pull a Docker image from our Docker Hub and then run it as a Docker image, okay. So let's go to our Docker Hub account, okay. So hub.docker.com, and then I have a Docker Hub account here, and let's see the image which we are going to use. So I have an image called Docker intro Spring Boot Hello World REST API. So I'm going to use it. So usually everyone will try to use Nginx. So, but we are trying to use it little different. So to show different things here. So we'll see what are those things. Okay. So let's go to the Docker fundamentals and then pull from Docker Hub and run Docker images. So let's start with the step one, verify Docker version and also log into our Docker Hub from our Docker client perspective, right? So let's go here and then clear. and I'll say Docker version, right? So it has given my client Docker engine version, which is 19.03.05, and also my server Docker engine version also been provided here. Okay, so let me clear this, and then I'm going to say Docker login so that I'll be able to authenticate to my Docker Hub account. Okay, so already I have provided the credentials earlier, so that's the reason it is showing. So I can even say Docker logout. Okay, so now it has been logged out. So if we want, we can even log in one more time. So I can say stack simplify. Okay, so my login got succeeded. So if I want anything in config.json, we can cross check. Okay, so nothing related to Mac OS X keychain. Okay, so that means we are good for now. So let me clean this, clear, and go back here. Okay, so now pull an image from Docker Hub. So for that, we are going to use just Docker pull, and the image you can see here, whatever is there, you can pull this image, or you can get the image name directly from our Docker Hub account here. Okay, so this is the one. So whatever we want, we can pull it, and here 1.0.0 -release. Okay, so I'll try to copy this complete command from here and then execute it for the convenience. Okay, so let me paste the command here. So now it is going to download. So that respective image is getting downloaded to our local repo. So let's wait for that to completely download. So now it is downloaded. So you have a command called docker images. Okay, so you can see here only one image, whatever we have downloaded, is available. So there are no other images other than this. So using docker images, we have checked the downloaded image. Okay, so let me clear this and then go back. Okay, so now run the downloaded Docker image and then access the application is our step 3. Okay, so you see this, there is a command called docker run to run our image as container on our local desktop, right? So let's see what are the options here, right? So the first thing is docker space run, and then hyphen name, and then I'm saying app1. So nothing but this is an optional thing. So what I'm trying to give here is like my Docker container name, I'm going to give it as app1. If we don't give, it is going to auto generate some name for us. Okay, but always it is good to give a Docker container name what we are going to run. So we are trying to use the best practice here. Okay, and the next thing is -p and then 80:8080. So here you see, right, the first 80 whatever you are seeing is your local port. Okay, which is nothing but you are going to expose from your local desktop. Okay, and the 8080 is nothing but the second one is nothing but your container port. So you are mapping your container port 8080 to your local desktop port 80. That's what you are doing here. So whenever you access localhost/hello, which is nothing but with port 80, your application is accessible, okay, with port 80, even though container port is 8080. So that's the thing. And -d and your container means like the image complete name including the tag value, right? So like this. So let's go and then copy this command now and then paste it and then run it. Okay, so we are going to run it now. So now we are going to see how it is running. Okay, so docker ps is the command to see the list running containers. Okay, so my container is running. Okay, it is created and its status and all those things we can see it here. Okay, so now the container name at the end you are seeing, right, it is nothing but app1 and its pointing is 80 to 8080. You can see all these things here. Okay, so now let's go to the browser and then say localhost/hello, right? So 2 else. Okay, hello world v1, you can see, right? So now whatever we have run it, we are able to access our application. So let's go back here and then list the running containers. Okay, and we have other commands also. If any other containers which is stopped containers are there, we'll be able to see them with -a. In addition, we'll have something called -q, which will give us only the container IDs. Okay, so if you want to stop the container, then you need just the container ID, right? So you can get that container ID and then stop it, or you can pass this command as input to another command. Okay, so for that purpose -q is used. Okay, docker ps -q is used for passing these container IDs to another commands for doing whatever we want. Okay, so when we are doing the advanced sections, usually we will know all those things. So moving on, so now we can even connect to that container terminal, which is nothing but whatever the Docker container, whatever we have created is a Linux container. So we can directly connect to that and see what's going on. So for that, the command is docker exec and then -it and the container name and then /bin/sh. Okay, so this is going to be something called paste, and my container name is app1 and then /bin/sh, right? So now I am in my container, and you can see here my app.jar is there, and then lot of commands are going to not work, only basic commands will work. You can see ps-ef, which is nothing but the Java command, whatever the Spring Boot application is running here. Okay, so now we are in our container. Okay, means like inside the container command prompt we are here. Okay, so I'm going to exit and then I came out. If you want again connect, you are in container. Okay, if you say ls app.jar, you are seeing ps-ef, you can see these things. Okay, if I say exit, again I came back. So I came back to my local Mac desktop. So like this, you will be able to connect to your container terminal. So if you want to stop the container, you can stop using container app1, right? So I can say docker stop app1. My container name is app1, so I am stopping it. Okay, so if I say docker ps, right, so no other containers are running. Okay, but if with -a, you can see the stopped containers. So you can see the stopped container you are seeing, you can see it here, exited 143, right? So but without -a, only running containers you can see. So now if you say localhost and then access it, it's not working, right? So now again one more time, it is a stopped container, you are going to start it. So and then say docker start app1. Okay, now your container is running. So when you say docker ps, you are able to see it. Okay, -a will give you the stopped containers, and without -a, you can see the running containers. Okay, so now it is again running. So let's access this and then say, okay, so hello world v1 is coming. That's good. Okay, so now you have completed the container stop and start. Finally, if you want to remove the container, you can say docker space rm and then container name. Okay, so let's do that now. Okay, docker rm and then container name is app1. Okay, you cannot remove a running container. Stop the container before attempting to remove it. So let's go there and then stop it. Now we have stopped it. So if we say -a, you can see that, and then it is in exited state. You can see it here, right? So now I'm going to say docker rm and then app1. So now my container is removed. So ps it doesn't show, and even in the ps-a also it doesn't show. Why? Because even the stopped container is removed from my mission. Okay, so with ps it is not showing docker ps, or with ps-a also it is not showing. So that's about it. Okay, finally if you want to remove the image, so you can say docker image and then image id. No, it should be docker rmi and then image id. So let me correct this. So whatever the downloaded image we have, just go ahead and then remove that image. So let's say first docker images, clear docker images, and then get the image id. So this is the image id. Okay, and then say docker rmi, which is nothing but remove the image, and then provide the image id. Okay, so now the docker image is removed. So let's say docker images, nothing is displayed. So whatever you have pulled from our Docker Hub is not available. So now it is plain empty. So no other images on my local desktop. So that's about the flow. Pull Docker image from Docker Hub and then run it. So we have done it in 8 steps, and then all these will be as a reference for you whenever you want to execute. Okay, so you can go to this Docker GitHub account and then use it. Okay, so I'll see you in the next lecture with our next flow. Until then, bye bye. Thank you. Welcome back. In the previous lecture, we have completed about pulling a Docker image from Docker Hub and then running it on our local machine. So now in 04, we are going to build a new Docker image and then run it on locally and then push it to the Docker Hub. Okay, so let's see how we are going to do it, right? So as a prerequisite step, please ensure you have your own Docker Hub account. So you can go to hub.docker.com and then create your account here. Okay, so you can click on sign up for Docker Hub and then provide your Docker ID, email, and then password to complete those things. Okay, so I already have the Docker Hub account. So what I'm going to do is I'm going to log in. Okay, so sign up for your Docker Hub account and then put it ready. Okay, now moving on, the next thing is to run the base Nginx container, right? So why we are going to run the base Nginx container, what we are going to do as part of this complete steps is, like, we have a Nginx Docker files folder here. Inside that you can find Docker file and then index.html. So whenever you run a base Nginx image, it is going to provide the Nginx related simple index.html. So what we are going to do is, we are going to change that to a different index.html, and then, so I'm going to say welcome to Stack Simplify Nginx v1 custom image, right, in the index.html. And in my Docker file, I'm going to say get the base image from Nginx and then copy my index.html, whatever I have created, to the USR share Nginx HTML, okay, which is nothing but inside the image to this location, copy it. And now if I run it, so obviously instead of default Nginx index.html, we are going to get our index.html. So that image, whatever we are going to build it, we are going to push it to our Docker Hub. Okay, so let's see how we are going to do it. So first, before that, let's get our base Nginx image and then run it and then see what it is showing. Okay, so in our previous step 3, means like in section 3, what we have done is we have used the docker pull command to get the image and then run it using docker run. But ideally, if you want to run it, you can, even without using the docker pull, you can directly use the docker run to do it. Okay, so what I'm doing here is using docker run, I'm saying -- name and then I'm saying my Nginx default. Okay, so my container name I'm giving as my Nginx default, and port mappings, my local host is 80 and also the container port is 80, and the image name is Nginx. Okay, so you can search for Nginx here, right? So and then you get the default Nginx image. Okay, so that one we are going to use. So I'm going to say docker run Nginx. Okay, I'm copying it and then going back, okay, to my terminal and then pasting it. So unable to find the image locally, so it will go and then download that image, okay, pulling from the library Nginx. So once it is downloaded, it is going to automatically start also. Okay, so it's downloaded and then started. So let's see docker ps, right? So whenever we see, it is already running. So let's go to localhost and then see what happens. Okay, so we can minimize this. So we can see here we are getting welcome to Nginx. So this is the default index.html of Nginx. So we are going to edit it and then change it. So that's what we are going to build, a new Docker image, very simple Docker image we are going to build with Docker file. So let's see how we are going to do it. Okay, so let's go here in the step 2, create a Docker file and copy our customized index.html here. So to do so, what we are going to do is, so we can go to any of the folders here. Okay, and in documents, I'll create a folder called mkdir, okay, Nginx image. Okay, inside that, I'm going to create the Docker file. Okay, so in Docker file, I'm going to copy these 2 lines, which is nothing but from Nginx, and then copy the index.html from local to this location, right? So let me copy these 2 lines and then paste it, right? So I have created the Docker file. So I also should have the index.html here, right? So I'll create the index.html and I'll say welcome to Stack Simplify. And I'm going to say Nginx. I'm not following any HTML standards or anything here. I'm saying Nginx v1 and this is going to be a custom image. Okay, and this is a simple file, okay, index.html. So now what we are going to do is we are going to build a Docker image and then run it locally, right? So docker build -t and then your Docker Hub ID / and your image name and then the tag you are going to use and where you are going to build it. Dot means like from current location it need to take the Docker file and then also the respective index.html file. That's the reason dot. So if it is in your environment, means like you have your own Docker Hub ID, right? So whatever you have created as part of prerequisites, so you need to replace this command with your Docker Hub ID here. Okay, so just if your Docker Hub ID is ABC, then just put the ABC here and then copy this entire thing and then run it. Okay, so Docker and then build the image -t, which is nothing but the tag name, right? So stack simplify / my nginx _ image1 : v1 and then dot. So okay, build from the current location, means the current location I have the Docker file, so build from there. Okay, so I'm copying this and then I will run it now. Okay, so now if I see Docker images, my new image, okay, so nginx already downloaded, and using that it created a stack simplify my nginx _ image1 with v1 tag, and it is created 4 seconds before. Okay, so now I need to run it, right? So let me clear this, and docker run -- name, and my image name is going to be my nginx1, and port mapping is 80:80, right? So if we don't stop this, then we are going to get the error. So let's go ahead and then stop our earlier one. So if you see, my nginx default is also using 80 of our local machine, right? So let me stop the old one. Okay, and then now come back here and then run this one. Okay, so docker run my nginx1 with port 8080, and my image name is stack simplify / my nginx image1 v1. Okay, so let's run it. In your case, you just replace it with your Docker Hub ID here. Okay, okay, you have run it now. So let's go to localhost and then check it. So it's coming.
Welcome to voice.
1 second. Ideally it should come. So it's coming from the local cache. So let me try one more time. Yeah, so now it is coming. Okay, so it came from the local cache whenever we tried here. So let me close this. So welcome to stack simplify nginx v1 custom image. We have got it. Okay, so now we have completed building the Docker image and then running it. Okay, so if you want, you can even stop it. Okay, so docker ps, it is running now. Docker stop my nginx1. Okay, and if you see docker ps, no other containers are running, but the stopped containers, you can see my nginx1 and then my nginx default. Okay, so if you want to remove them, you can even remove them. Okay, so I'll say my nginx1, and then all these things you can do via additional command now. Docker ps -a-q, right, which is nothing but it will give the Docker image, Docker container IDs. Okay, so you can even remove them using this command. Okay, so now if you say docker ps -a, nothing is there. Okay, so that's the reason why we are going to use -q, is because to get the Docker container IDs or Docker image IDs and then pass this output to another command like this. Okay, so earlier we discussed this, right? So for that purpose I have executed this command and then shown it, even though it is not in our current things. Okay, so now moving on, we are going to tag and push the Docker image to Docker Hub. So currently our Docker image name is my nginx _ image1 : v1. Okay, so but what I felt is like, oh, v1 is not my not looks good, so we'll say v1 -release. Okay, so then if I want to change my Docker images tag name, then we can use the docker tag, right? So docker tag command to do that. So let's do that now. So docker images, and we'll have the stack simplify my nginx image1. So let's say docker tag and then stack simplify my nginx image v1, change it to v1 -release. Okay, so let's change that, right? And if you see the images, so now you have both v1 and then also v1 release. Okay, so now let's push the v1 release to our Docker Hub account. Okay, in your case, please replace your Docker Hub ID at every place wherever you see the stack simplify, right? So now I'm going to push this. Okay, it is pushing to my Docker Hub. So let's see once it is pushed. Okay, so let's go here, Docker Hub, right? So this is my Docker Hub and my repositories are here. So let's wait for it to be completely pushed, and once it is pushed, we can cross check whether it is available on our Docker Hub repositories or not. Okay, it is pushed now. Okay, so let's see, the next step is to verify the same on the Docker Hub. Okay, so let's go here and then refresh it. And you can see my nginx _ image1 just now came updated a few seconds ago. and you can see the tag name is v1-release. So this completes the creation of a new Docker image, run it as a container, and then push to the Docker Hub. Okay, so we have seen that in a series of 5 steps. Okay, so I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. So in the previous lecture, we have ensured that we have created a new Docker image. We have built the new Docker image and then pushed it to the Docker Hub and then verified it. So now we are going to see few essential Docker commands. So most of them already we have used and then we have implemented so far in our last few lectures, but we can again one more time have a look into it. Okay, so Docker PS, which is nothing but list all running containers. Docker PS-a, list all containers stopped and then running, so both. Okay, so and then Docker stop and then container ID, stop the container which is running. So either it is a container ID or you can give the container name also. If your container is named with -- name when you are running it, Docker run and then -- name if you have given. So then when you are stopping it or starting it, instead of finding the container ID and giving it, you know the name, then you can directly give the name. Even for start and then restart also you can use those. Okay, so Docker port container ID will provide you the list of port mappings of a specific container, and for removing the container, either container ID or name you can provide. Okay, and Docker remove the running containers forcefully, you can use -f as the one of the argument. Okay, so and if you want to see the image info, pull the image from Docker Hub repository. So Docker pull and then image info. Image info is nothing but the complete image name. Okay, and pull the image from Docker Hub repository. This is an additional example for whatever we are seeing here. This is the example. So in addition, you are seeing the Docker exec -it and the container name and then /bin/sh to connect to the Linux container and execute commands on that respective container. So which means connect to the container and then execute commands or verify something, you can do this one. Okay, and if to remove the image, Docker RMI, and to log out from our Docker Hub account, Docker logout, to log in, Docker login, and then to display live stats of our container, Docker stats. So to display the running processes of a container, Docker top, and finally you see here the Docker version. So there will be lot of sub commands under Docker run and all those things, but on a very high level to manage Docker, these are the core commands which we should be aware of, and more commands will be adding the more when we are gaining experience on the Docker by implementing multiple use cases. But from fundamentals perspective, how to stop container, start container, what is an image, how to download the image, how to run the image, and how to remove the image, and how to remove the container, or how to connect to the container terminal, all these things are required and all these things are listed here. So this completes the essential commands overview for Docker. So I'll see you in the next lecture. Until then, bye bye. Thank you.